the social science discussion group. Really delighted to have a colleague from Manchester. Of course, Rob is former colleague at Manchester and now Riza, so it's kind of like maybe a takeover of Manchester today. So Riza Batista-Navarro, senior lecturer, I think, in text mining at Manchester University, working on some really fascinating work on using natural language processing methods to understand content of tweets, and particularly here I think this idea of populism, which is a fascinating and very challenging topic, which I'm absolutely fascinated to find out how Riza might have pushed us forward to be able to kind of capture this. So Riza, I think at the end we can talk more a little bit as well if people are interested in further collaboration and come back to that, but just to say thank you so much for presenting your work. I know that this is not only populism is not the only area that you focused on, there's kind of broader areas as well, but for today you're looking at the sort of political side of it. So so please, you're already sharing your slides, so I'm just handing over to you, and we're looking forward to it. Thank you.
Thank you. Thanks very much, Rachel, for the introduction. So yeah, like Rachel said, I have other areas of interest. So actually, I started with kind of looking at hate speech detection as well, which is quite related in the sense that it's also a text classification problem. But for today, I instead want to focus on how we can detect populist speech, in particular from tweets. So this work was actually led by a former undergraduate student. We're doing some ongoing work together with colleagues from economics, so Carlo and Genia. And so yeah, without further ado, I'll get on with it. So yeah, if we look at this slide, so here I have images of a few people whom I believe some would be familiar to some of you. So these are all politicians. And there's actually one thing which is common amongst all of them. And it's nothing to do, it has nothing to do with all of them being right-wing or all of them being left-wing politicians, because some of them are actually right-wing and there's at least one who is left-wing. So what they do actually have in common is that they all have used populist rhetoric, and they have used that effectively to the extent that they have achieved some electoral success to some degree. Now the problem is, in some cases, the use of populist speech or populist rhetoric has led to members of the public to respond in an aggressive or antagonistic way. So for example, if we take the case of kind of the riots that happened in the US Capitol a couple of years ago. So it's kind of well known that
I think somebody has their mute.
Yeah, sorry, somebody has their mic on.
Just if anybody's got a mute, can they just make sure that they're muted?
Yeah, I think we're okay. Yeah. So thanks, Rachel. So yeah, I was just saying that this is this kind of use of populist rhetoric is actually on the one hand it's tricky, because on the one hand obviously people have kind of freedom of speech, but on the other hand it could also undermine democracy. So now I'm gonna take a moment just to define what populism is. So in the literature, this is known as a political view, which is defined by the separation of society into the pure people and the corrupt elite. And then these two kind of entities, the pure people and the corrupt elite, are always in opposition with each other. Populist leaders always try to claim that they represent the people, and then they position themselves as opposing the elite. Populism is also known as perpetuating a state of crisis. So essentially, a populist leader would always talk about, the country or the people being in a state of crisis, and then they would present themselves as being the solution to this crisis. So what we aim to do as part of this work is to develop some automatic or computational methods to try to detect if speech actually conveys populism. And here, the task is a simple text classification problem, specifically a binary classification problem, where the input is a piece of text, and then the output is a label which says whether that piece of text is populist or not. How it differs from prior work, or rather maybe just to give you an idea of what has been done in this particular problem in the past, there's not a lot. There is one piece of work called Us versus Them, which basically was completed in 2021. It's a bit different though, because it's more focused on detecting the degree to which certain groups, especially minority groups, are being discriminated against through the use of populist rhetoric. So it's a bit more focused, and it's a bit more focused on kind of minority groups and how they are affected by populism. So I will start by discussing how we collected our data, because like I said, although there's previous work, and that previous work I just mentioned, they also have their own data set, it's not fit for our purpose. So we had to collect our own data, and we started by retrieving a list of all candidates to the 2019 UK general elections from the House of Commons library. So if it's very easy to, if somebody looks it up, it's very easy to find like a website in the House of Commons, hosted by the House of Commons library, which basically has the spreadsheets or the data pertaining to the results of the 2019 general elections. So this spreadsheets would have the names of the candidates, the corresponding constituency, and whether they won or lost in the election. And then for each candidate, so now that we have the full names of the candidates, so what we did is that for each candidate, we tried to identify their Twitter username or their Twitter handle. And how we did that is by using a website or a platform called Politics Social, which actually has a listing of all the candidate names and the corresponding usernames on Twitter. Now, how we did it is by matching both the full names and the names of the constituency. However, as you might expect, not everyone is on Twitter. So not all kind of candidates are on Twitter. And at the same time, that kind of matching of names and constituency didn't always work. Yeah, so sometimes there will be some variations in the names because we are using different data sources here. One that comes from the House of Commons library and another from Politics Social. So to handle such cases, we had to do some manual checking as well of unmatched names. And after doing that, now that we have the Twitter handles or the Twitter usernames, then what we did is to retrieve the tweets posted by each username using the official Twitter API. And basically, we did it in a window so that we can capture all of their tweets from 2 weeks before the 2019 general election up to 2 weeks after the general election. So we got a lot of tweets out of that process, from that process. And what we did next is to randomly select 1,000 tweets, to anonymize them by removing any usernames that appear in the tweets. And then we conducted an annotation task, a manual annotation task. So what we did here is we involved or we recruited 3 different annotators. And they have the task of assigning a label to these tweets. The first type of label is essentially to say whether a tweet is populist or not. And then the second type of label is to actually select a reason as to why it is populist. The reason why we ask for the second type of label, to specify a reason, is because we wanted to make sure that, it doesn't just look populist, that there is actually something in the text that corresponds to to any of these characteristics. And these characteristics came from the literature as well. So essentially, in the literature, they said that, you know, when we're talking about populist language, these are the 5 kind of, you know, characteristics, or when we put it another way, if something is populist, then it should have at least one of these characteristics. So I will quickly go through them. So the speech should constantly refer or advocate, it should constantly refer to or advocate for the people. Or it tends to use personal pronouns to connect with the audience. So the use of you or I or me. And why, you know, in doing that, the intention is to create kind of a separation between us and them. Yeah, so to have this kind of us versus them mentality. Or the language used is calling out and criticizing the elite, again, you know, because of this kind of opposition with the elite. There also it tends to use metonymies, so, or in other words, using alternative words to describe what is factually meant. So let's say an example of a metonymy is number 10, you know, so number 10 is literally, I don't know, a place or a door even, but it's used to represent you know, to refer to the prime minister, essentially. Or the language would emphasize victimhood of the audience. So essentially, we ask our annotators, you know, when they say that something is populist, they necessarily have to select one of these reasons. So we have 3 annotators, as I mentioned. So the first annotator, who is the primary annotator, annotated the full set of tweets, whereas the second and third annotators annotated kind of a 60% only. So they have some overlap between the 3 of them. So after that exercise of annotating, we measured inter-annotator agreement between the 3 annotators, and we have measured that using F1 score. And the average F1 score is 73%, which is reasonable. And for deciding what actually goes into the final annotations, then we used majority vote. So how we did that is, for a given tweet, if all 3 annotators labeled it, then it's quite simple, because then we just take the majority vote and then we use that as the gold standard label in the data set. But if only 2 annotators labeled it and they agreed, we simply take the label, obviously, as well, because you know, we still have majority vote in that case. However, if only 2 annotators labeled it and they disagree, then we ask the third annotator, who didn't annotate it initially, to label it as well. And then we repeat we apply the same process of majority vote to that. So in that way, we obtained kind of a final set of tweets with annotations. And analyzing the frequency of the labels, we found out that, you know, similar to a lot of text classification problems and data sets, the data or the labels, the distribution of the labels is quite imbalanced. So only 20% of the tweets are labeled as populist, and the rest are non-populist. So what we did is that we discarded or we did some removal of the non-populist tweets, retaining only the same number of tweets, so that it's equal to the number of populist tweets. So then this gives us a final data set with only 404 tweets. We split this into 70%, 30% partition, 70% for training, which basically means that we have 141 tweets which are populist and 141 which are not populist in the training set. And then in the test set, we have 61 tweets which are populist and another 61 which are non-populist. And if we visualize, if we separate if we have the visualization using a word cloud for each of the populist tweets and the non-populist tweets, so then we do see quite interesting patterns, because from the populist tweets, then it's clear that we get words like people, for example, country, as another example, whereas the words in the word cloud for the non-populist tweets kind of tend to be more generic, I would say. and not, not immediately, I can't see immediately any words which are kind of more associated with with populism. So now I'm gonna go through the different types of methods that we developed to solve this problem of text classification. So I'll start with the rule-based method. So essentially, this was inspired by a method that was developed from the social sciences, actually. So what they did is they used a precompiled dictionary of 33 populist words. So like in the literature, another researcher compiled these populist words into one dictionary, and then they use this dictionary in their method. It's important to note that in this dictionary, the words are labeled as either referring to the elite or referring to people. So now that we have the dictionary, what they did is they computed the term frequency, inverse document frequency for each of the dictionary words. And this computation was based on a corpus of speeches from the American Presidency Project, which has 226 speeches. So this is what they did. Yeah? So Gennaro et al. This is what they did before. And then based on the TF-IDF, they can then calculate a measure of populism for each document, which in this case is a speech. So this is just a formula which looks big, but really all it's doing is to get the summation of the TF-IDF values for every word in each of the elite subset of the dictionary and the people subset of the dictionary. And basically what the two summations for the elite words and the people words need to be more than 0. And if that condition holds, then they take that value as the score for populism for that document. Otherwise, it's just 0. Now, I'm explaining this because what I'm saying is that in our approach, we firstly tried to apply the same idea after doing some pre-processing, such as case folding, removal of stop words, punctuation, and hyperlinks. And also after a bit of stemming, because the words in the dictionary are also stemmed. However, as you might predict, the words that were precompiled and that were in the precompiled dictionary, they kind of have a mismatch with the words with our data set, which consists of tweets. So as a result, only 14 of the words in the original dictionary were matched in our own data set. And this can be attributed to, for example, the difference in language use. Yeah, so as everybody knows, the type of language you use in social media is different from, from let's say speeches or news and so on. But also in the previous work, they were using American speeches. So, for example, they would refer to what we know in the UK as NHS. They would refer to it as the British National Health Service. So again, I don't think anyone in the UK really refers to it as the British National Health Service, but also talking about tweets and social media, nobody refers to it. Nobody refers to the NHS by its full name, but rather we just say NHS. So what we did then is to create a custom dictionary. And how we did this is by taking the 33, we took the same number as in the original dictionary. We took the 33 most frequent words relating to the elite or people from our own training data set. And just as a means of checking that dictionary has better coverage, then we confirmed that all of those words drawn from the training set actually also appear in the test set. Then we also explored more traditional machine learning based methods. So we did the same pre-processing steps as before, like case folding and stemming and so on. We also used TF-IDF as a way to represent the features in a document. And then we made use of several algorithms. So we started with naive Bayes. Essentially, this is just like a Gaussian model, right? Learned from the training set. We also use support vector machines, or SVMs. And here I just list down the hyperparameters that we used for training the support vector machines. And we also wanted to compare with random forests. And again, here I list the different parameters that we used in training the random forest. And then nowadays, as most of you or all of you probably know, the state of the art in NLP kind of lies in deep learning based approaches. So obviously, you know, it will be a sin to not try them. So we of course explored their use, starting with the use of a BioLSTM model, or a bidirectional long short-term memory model. So this also takes as input the pre-processed tweets, but this time for vectorization, instead of using TF-IDF, we made use of pre-trained Glove embeddings, specifically the ones which were trained on Twitter data. So for the curious ones in the room, so this is how the architecture of the BioLSTM model looks. And then again, the state of the art in deep learning methods are based on what we call transformer models, or as most of you or all of you would have heard, BERT models, which BERT standing for bidirectional encoded representations from transformers. So essentially, in a nutshell, how it works is that we have a language model, which is essentially pre-trained on unlabeled data. And the unlabeled data is just kind of, you know, natural language text. And this language model then becomes fine-tuned for more specific downstream NLP tasks, for example, text classification, question answering, name entity recognition. So essentially, under the hood, BERT is a language model, but you know, you can fine-tune it to whatever application or specific task that you want. So in our case, we took the BERT language model and essentially added a layer on top of that, so that it will output a class label. Because again, as I said earlier, our task is simple text classification. So if we apply that to like the specific populism detection task that we have, so then the input will be a tweet, right? And then that will be fed to the BERT model with the classifier with the classifier layer on top, and that will predict the probabilities corresponding to the input text being populist or being not populist. So there are a lot of options to choose from in case of what specific implementation of BERT to use, or which type of BERT model to use. So in our case, we explored only two. So we have the BERT large uncased model, which is trained on kind of, you know, a lot of English data, but generic English, yeah. So not specific to tweets. So this particular model was fine-tuned on the text classification task using our training data set for 3 epochs, using the Adam optimizer and the binary cross entropy as loss function. And then we also explored another language model called BERT tweet. And this time, this language model is specifically fine-tuned on Twitter data. So we trained it using the same parameters, except for we trained it for a bit longer, for 8 epochs. So the next part of my slides will be telling you about whether it actually worked or not. So I will start by clarifying which metrics we use. So these metrics probably need no explanation, but essentially it's the standard precision recall, and then the harmonic mean of precision recall, which is F1 score, and then accuracy. So starting with the rule-based method, so comparing the performance of the rule-based method, if we use the precompiled dictionary, then as you can see, the F1 score is quite poor, 10%, and the accuracy is 50%. If we use the custom dictionary, which is adapted for Twitter or for our own data set, then the F1 score increases a bit to 35% and the accuracy to 53%. However, that's probably not, not that acceptable nowadays. So with the traditional machine learning methods, we have better performance. So specifically with the naive-based model, we're getting an F score of around 71% for the populist class, for example. So that's quite an improvement from the rule-based method, and an accuracy of 65% and the weighted average of 63%. With the SVMs, how that compares with the SVMs, so the SVMs are doing a bit better, as you can see here. And then the random forests even a bit better compared to the SVMs. And we are getting as much as 72% of accuracy. And here, it's kind of acceptable to use accuracy as a metric because the test set, if you remember a few slides ago, is balanced in terms of the distribution of the populist and non-populist labels. And then with the deep learning based methods, just to compare between them first. So the performance of the BioLSTM model is a bit similar or comparable to the performance of the traditional machine learning based models, around 70% accuracy. And then if we compare now with the models which are based on transformers, then we do see an increase, a noticeable increase. So with BERT large, for example, we get an accuracy of 77%. And a weighted average of the F1 score of 77% as well. Whereas finally, for the BERT tweet one, which is the one which is using a pre-trained language model on tweets, we get the best performance so far. Essentially, we're getting 80% accuracy. And then, for the populist class alone, 83%. So, okay, so here I'm just presenting the summary, of all of this of these methods, so that we can see easily how they compare with each other, across the board. So it is clear that from this that the classical or the traditional machine learning algorithms are getting around 70%. That's a huge performance improvement compared to the rule-based methods, which made use of dictionaries. And then the attention-based models, which are basically the same as the transformer-based models, which are the state of the art in the literature, are able to get even better performance, with as high as 80% accuracy. So, yeah, so this is actually my last slide. So I just want to finish the talk by giving a summary of the key findings. So I guess one interesting finding is that even with a relatively small training set, so if you remember, we have only kind of a total of 404 examples, we can achieve reasonable performance. However, what that also means is that we only have quite a few examples in the test set. So one way to make sure that the test results or the evaluation results are actually kind of rigorously obtained would be to label more tweets, if only to expand the test set. But it's still promising because it shows that nowadays it's not necessary anymore to label thousands of data points or samples just to train a good performing model. Perhaps unsurprisingly, expectedly, a domain adapted language model, which is BERT tweet, obtains better performance than a generic language model. And this is despite the fact that the generic model is the large version of BERT, whereas the BERT tweet model we use is just the kind of the vanilla version of it. However, one thing that is also noticeable is that if we go back to this slide, There is a huge difference between the precision and recall for the populist class. So the precision being, lower than the recall quite substantially. So what that means is that the model tends to overestimate. So it would tend to say that something is populist, even if maybe it's not really populist. So that is obviously another room for improvement. And then on part of our ongoing work is to try to perform exactly the same experiments, but this time for the 2017 UK general election, and to see and to compare whether we get similar results, or if there's any difference at all. And then the other interesting question would be to see whether a model trained on the 2017 data, for example, how that performs on a test set for 2019, and maybe vice versa, just to see if there has been any change in language between the two elections. And maybe this is a very important point, is that in the literature about populism, they also say that populism is actually should be looked at the level of the person rather than one speech or one tweet in this particular case. So it's more about looking at how frequently does the same person use a particular type of speech over time. So I mean, we wanted to develop a proof of concept, so we started with looking at it at the document level, but it would be interesting to see how that actually translates to when we look at the person level, like at the level of the same politician, and what the kind of language that they use during a specific time period. So that's really the gist of what we're currently working on. And as Rachel said earlier, I'm interested in collaborating. So if anybody has any feedback or is interested in this area, maybe, because for example, there are a lot of analysis that can be done outside of the NLP part of it, so what can you do once you have segregated tweets into populist and not populist. So we haven't even done that or we haven't even looked into those kinds of applications. So if there's anyone who's interested in doing some follow-on work to this, then I'd be more than happy to discuss. So I've left my email address here if anyone is interested to get in touch. So thank you very much for your attention and for having me today.
Thank you, Riza. Do you want to go back to unsharing the screen?
Yes, there you go.
Brilliant. Thank you very much. Okay, so we have quite a lot of people in the room actually. So I guess I'll open it up to the floor. If people have questions, I can check the chat. But also if you want to raise your hand, Rob's giving you a clap, so there you go. Then I can switch over to questions. So I'll open it to the floor if anybody would like to put a question. Oh, I think we have. Carolina. Yes, I see. Yeah, thank you. Hi, Carolina.
Hi. Thank you, Rachel. Thank you, Riza, for the very nice talk. It's a very nice topic. I'm just curious whether you looked into other languages as well, or if your work is mainly on English, or how do you see that the same kind of process could apply?
I see. That's a very good question. No, so we haven't looked into other elections and then other languages for that matter. But it's an interesting point because I would like to think that the same framework could be applied to another language. So for example, when I started to talk about, let's say, using rules, if, for example, for starters, that's something that one would want to explore. So, it should be possible to compile your own dictionary. But also for let's say, but if you want to do the other extreme, which is, look at the state-of-the-art models like BERT, I mean, these language models, there are many versions of them which are pre-trained on other languages individually, and there are also versions of them which are actually multilingual, as in trained on many languages at the same time. So yeah, like I said, I don't have the numbers to show for it, or, haven't done that work, but I think, it's worth exploring. It's more about maybe creating the corpus, which would at least allow you to fine tune the transformer-based models on, like I said, even just 100, well, maybe not 100, but a few hundreds of examples with labels.
Thank you. Yes, definitely. And I think it also, if we use these multilingual models, we could even think about zero shot, right? So
Yeah.
take your labeled data and then try to, I may drop you a line because I have quite a lot of data for Brazilian elections.
Okay, yeah,
So
that's interesting. Yeah.
Yeah.
I was tempted to put Bolsonaro's photo, but I said, oh, I have too many photos now this time. Yeah, okay, yeah, that's interesting. Yeah.
Yeah, that's an interesting one. And if I may, can I ask a second question? Sorry. So the second question is whether it would be interesting or even possible to identify. So whenever you move to look into a person, whether a person has a populist speech,
Yeah.
whether we can quantify whether they have always been like that or if they changed along the way.
That would be interesting. That's also why I mentioned over time, because maybe they weren't like that, but maybe, I don't know, as a response to something, they started to adapt certain types of language. So yeah, that I think that would be worth looking into in this kind of person level, but also over time kind of analysis.
Thank you.
So yeah, please do drop me a line.
I will. Thank you.
Thank you, Carolina. I think we have another question. Is it Nurhan?
Yes, sorry, I can't open the camera. It has a problem there, but hello, Riza.
Hello, I remember you from Leeds, no?
Yes,
yeah.
we met earlier this year. So it's a very interesting talk, and thank you very much for your excellent presentation. I have a small question. We are conducting a study on bias detection in education.
Yes.
So we are trying to come up with some rules like the ones you mentioned in your presentation for annotators to follow.
Yes.
So how do you know that these rules are really, comprehensive? They are, how did you do that? How did you come up with a set of rules, and how did you test them?
Yeah, that's a good question. So yeah, in this case, the rule-based method that we adopted, I should say, that's actually based on somebody else's previous work. So in a way, that's kind of our baseline approach. We wanted to we just wanted to replicate something that other people have done before, and I guess what I'm trying to say is that that's the thing. It's really difficult to come up with a comprehensive set of comprehensive set of words that will go into your dictionary, right? Because you have to well, first of all, you have to have a way to compile the dictionary, in a way that you think it's more or less complete. Yeah, and it's very difficult to generalize those rules because, like what I demonstrated is the moment that you try to apply the dictionary and the rules to a different data set, then things could easily break. You see what I mean? So they're not very generalizable. That is the problem. So I think, but if you are using rules at the moment, I would say start with kind of, if you're using a dictionary as well, then I would start by kind of, adapting the dictionary as much as possible, like what we did, right? So instead of using the dictionary that was pre-compiled by somebody else before, instead we came up with a custom dictionary which was drawn from the data, the training data that we have. So maybe, and that led to some increase in the performance. So maybe that's one way of kind of, trying to make the rules or the dictionaries work in the first instance.
Yeah, and for the manual annotators, you also developed some set of rules that they need to follow.
So what you meant, sorry, maybe I misunderstood. You meant like the choosing the reason. So that, luckily in this case, those reasons are kind of well known in the literature.
Okay.
So it's more like, you know, kind of social science researchers have long ago studied what makes you know, language populist, and these are the things that they kind of identified. So, you know, we didn't even add to those rules, or, you know, we didn't even try to modify or enrich those rules. We just took them from what the literature basically said. So and yeah, and I recognize that not all tasks are like that, right? So sometimes you have a task and you have to develop your own kind of, you know, guidelines, and that is difficult. So I guess my general advice would be, if in your annotation guidelines, you always have to trial it with your annotators to see, you know, before actually running the main annotation task, you know, trial it first and then see if you're getting kind of reasonable annotation, so to speak, or if the annotator agreement is reasonable, and then iterate again, you know, because you might have to update your guidelines and so on.
Yeah, thank you very much, Riza. Thank you.
Thank you.
I have a question, but I'm just checking in case anybody else has got their hand up. Yeah, I think my question actually probably links a little bit to Carolina's research, which is to do with the kind of comparative aspect, a little bit of the research. And I was more thinking, not necessarily about language, but well, two things actually. The first thing was about the specification of the elites. Like you mentioned the fact that there's kind of like a part where you have to plug in the names of the prime minister, or the names of, you know, who are the kind of,
oh yeah,
if you tried a version, like different variants on that, and like, you know, how you decided on like, well, these were the names that we kind of most consider to be seen as the in group and we're the out group. And then again, thinking that through, is there almost like a categorization that you could use, that you could then say, well, actually, we can find the same set of elites, but we'll just put it into the context of the US, for instance, or so it's like it allows you to kind of be like more comparative, because it's not so specific to the UK, but you have kind of types of actor that you then.
Oh, I see it. Yeah.
Yeah. So yeah, it was just about that kind of definition of who the in groups are, and whether or not you tried to kind of alter it a little bit, and did that affect your results?
No, not really. We didn't look. So we took a very, I should say, data-driven approach to it. So essentially, when we, for example, when we compiled our own custom dictionary, we just took the most frequent words, which, you know, which look like they pertain to, you know, the elites and the people. But we did, and then we took only, you know, 33, you know, so we didn't really do any fine tuning. So what that means is that it would be very specific to the UK context, because that's what our training is about. So you make a good point, because what that means is that probably that approach will again break when applied to, let's say, US elections.
Yeah, and I'll just follow up on that in the sense that we've been looking at the US context in 2020.
Yeah.
And we've kind of generated a list of accounts from we have a survey component where we've asked people to share their Twitter data.
Okay.
We've been able to kind of look and see to what extent people, like which accounts they were following, you know, during the course of the campaign.
Oh yeah.
And we've kind of separated them at this point into what we've called candidates or parties. So the kind of official campaign actors,
yeah,
and then traditional news media actors, alternative news media actors, and then what we're calling like OPs, which are online political influencers.
Oh, I see. Yeah.
People that are more informal. So we kind of have these categories of sort of influence. And what would be really interesting, I'm just thinking, would be to kind of look to say, because our hypothesis is that the populist sort of element is probably stronger perhaps in the OPs, in the alt media. And then certainly perhaps for the candidates, perhaps for the, you know, the Republican Trump kind of, you know, so, but we haven't really got a way of actually testing that. And that would be kind of something where it would be really useful. So I'm just thinking as a collaboration, like down the line.
Yeah, that would be interesting. Yeah, maybe that's something we can follow up on, definitely. Yeah.
I see Rob, you have your hand up. I'll pass the floor to you.
Thank you. Yeah, I suppose this is in a way a sort of follow-up to what you were just talking about, Rachel, which is, I was wondering, have you applied your classifier over a large set of tweets to profile and get a feel for the preponderance of populist tweets in current discourse on, say, on particular topics?
That's a good question. So
And just a related remark is, of course, you say that populists set themselves up against elites. Well, of course, there are many different kinds of elites that may be targeted in that way, and some of them are clearly racially identified. You know, Jews are often referred to as being part of some sort of elite, and so on and so forth. But also perhaps other types of target for populists. So I just wondered, you know, if you're thinking about any kind of follow-up to look at what these elites are that these populists are targeting, as well as looking at the amount of populist posts on social media and what sort of topics that they reflect.
Yeah, that's a very good question. So about the first one, so we did want to do that, you know, to kind of apply it at large scale to many other tweets. We haven't done that kind of officially or you know, properly. The reason being, we hesitated because, like I mentioned in my slides, even the best model we have, the precision is not so good, you know. So it's good at the recall, but then the precision is not so good, and what that means that is it overestimates. So I was a bit worried that, you know, it would flag up somebody as populist, even if they're not populist, you know, especially because we're still doing it at the post level. So I thought that, you know, maybe, you know, at its current state, maybe it's not yet ready for, like, you know, application at large scale. But it would be interesting to do that, you know, especially if we're able to bring up the precision a bit better, and then we have more confidence that, okay, if somebody is, or if a post is flagged up as populist, then yeah, it's really more likely or really likely to be populist. So yeah, and then but yeah, definitely that would be interesting for follow on work, and again, if anybody is kind of, you know, interested in collaborating, that is something that we'd be happy to do. About the point on different types of elite, so yeah, I agree that I think that previous work I mentioned, the us versus them papers, is specifically looking at kind of, you know, this specific groups. We didn't look closely into that at this point. So when we ask our annotators to identify the reason, and if the reason happens to be something to do with referring to the elite, we didn't really kind of, you know, do any further analysis yet as to, you know, is this really, you know, referring to a certain type of elite groups, or rather, sorry, is it associating it with certain groups as being elite? So we didn't look closely into that. But if you're curious, then I would recommend that paper I cited, the us versus them work. But again, as part of future work or follow-on work, you know, this is a possible direction as well to go with.
Thank you. I'm here with a colleague who we're sharing a laptop, and she has a question she'd like to put to.
Thank Riza for your presentation. I have a question. I think like you have explained it before, but I was thinking of one of the application. Have you thinking of using the result to compare with electoral result? For example, like in a state where the candidate have like populist vote, will the candidate get elected?
I see what you mean, like a correlation between the success in the elections and the population. So yeah, we haven't done that kind of analysis as well. And I think that's one of the things I explained, that, you know, this is just looking at the NLP side, not even kind of the potential implications of the results. So we haven't done that kind of, but yeah, I agree, that's also one of the use cases.
Okay, I don't, oh, hold on, I'll just check the chat. I don't see any more. Yeah, I don't see any more. Carolina, yes, please. We still have time.
Sorry, me again. Just a follow-up from the last question. I just got curious if you looked into like the people interacting with these candidates on Twitter, whether they also had the same type of discourse.
No, we
or-
haven't looked into that. We did because we were using the Twitter API anyway. So we did collect the information on like the followers, for example, of the candidates, and the conversations. I think that's a technical term in the Twitter API. The conversations between the candidate or the Twitter user and the followers. But we haven't done any analysis yet on the actual tweets. For now, we're just looking at the tweets of the candidates. So again, another
Thank
one
you.
of those follow on kind of potential follow on collaboration.
Yeah, definitely. Thank you.
Yeah, I think this has got like a lot of translation into many sort of other contexts. So it's like you're really onto something here. I think it's very difficult to
I just wanted to address, I think there was a comment in the chat that, yeah, so indeed, you know, when we apply it to the 2017 election, though, yeah, it's worth noting the difference between the length of the context in the tweets, because obviously, yeah, I think back then, I agree, it was limited to 140 characters. So, you know, so that would be a curious thing to investigate as well, whether that actually makes a difference to the performance.
I think I'm not sure if Juan had a hand and then it went, but did you? Yeah, hi.
No, it's just it went up and down. Sorry, but
Oh,
thanks
no.
for the presentation. I mean, maybe my question was whether you have a working paper we could read. I was really very much surprised by the very small sample to how effective you were with only 1,000 tags. So that was my question, I guess.
Yeah. Okay. Yeah. We don't have a publication yet. That's the thing. But yeah, it's something that we might publish this work, but more for an NLP audience. But definitely, would be happy to follow up and yeah, especially if we manage to do the kind of the applications.
And could you say something about so you said you maybe that's what I remember, you tagged 1,000 tweets.
Yes.
Well, that's a small sample for I thought.
Yeah. Oh, sorry, you mean to say you were surprised? That's what you were saying. You were surprised that even with just a small sample. Yeah. That we were also pleasantly surprised, if honest. So the reason why from the get-go we decided to sample only that many is well, first of all, lack of resources. So I think I mentioned from the very beginning, this was done by an undergraduate student who, so it's not a PhD student even who had kind of a lot of time. But also it's a combination of the practical reasons, but also we did want to challenge whether these transformer-based models can really be fine-tuned on such a, just a small limited amount of data and still get some reasonable results. So what I'm saying is that when we started to get 80% on that data, we didn't really see the need to increase the data. But as I said in the future work slide, I do recognize that there is benefit to doing that, if anything, just to make the test more rigorous, right? Because right now we're basically testing on only 100 or so tweets. So that would be, that could be a reason to get more tweets labeled.
And what about the length of the tweets? And so the fact that they are tweets 140 characters, I mean 2017. Do you think that has to do as well with with the effectiveness, and with longer text you might need a larger sample or not? I mean,
at this point, I don't think. I think what's happened is so I'm just going to talk about the best performing model so far, which is the one based on BERT tweet. So I don't think whereas before it used to be a problem, dealing with tweets because you have limited context and so on. Before the vectorization or the representation of the tweets would be based on things like TF-IDF, which would mean you would have sparse vectors. And that's the problem why the performance wasn't so good. But now with this kind of language, this language models like BERT, especially BERT tweet, which was pre-trained on tweets themselves. So you see what I mean? So it kind of doesn't have an issue with that, because it sees the language used in tweets, and so they're all kind of the same, messy short texts anyway. So I think that's also one of the reasons why it was kind of successful to some extent, this model. No, you're muted, Reisha.
Yeah, I think I muted on mute. So I'm going to say, I think we're at the 3 o'clock mark, right? So we've expended our hour. Thank you very much again, Riza, for really fascinating talk. Like I said, I think it's sparked a lot of ideas and thinking, certainly on my part. So it's good that you're at Manchester, because I can see.
Yes, thank you.
Yeah, and then thank you everybody for attending this week. I don't know, Rob, is there anything? Is there anything you wanted to announce for next time?
Just to say that the next talk will be in a couple of weeks, 2 weeks today, in fact, same time, and that will be broadcast through the mailing list at the start of next week. So look out for that.
Thanks
those of you
very
on the
much.
mailing list. And if you're not on the mailing list, go to the Turing website and complete the form to get yourself added to the mailing list.
Good. And you can catch this on
Social
YouTube.
data
Well, I'm not
science.
sure. When does it end up on YouTube, if people wanted to share it with us?
As soon as possible.
Okay. And they can contact
The
you.
formalities have been completed.
Yeah.
Great. Okay, well, thank you very much again.
Thank
Riza.
you. Thanks for having me. Thanks, everyone.
Thank you very much.
Bye.
Bye-bye. Bye-bye.
Bye.
Right.